Okay, can see the textbook? Siranya, can see textbook? Siti Farah, can see textbook?
Can, sir.
Okay. So we'll start with the lesson. Okay, so this is today index, optimization in a linear programming. Okay, so this is the last part already actually for this chapter. Today is 30th. Okay, today will be the last day of the June. So means the whole year we have passed half of the year. Okay, exactly half. Okay, we go through this. Okay, X chocolate cake. Okay, the cost is 4 ringgit 1. Okay, and then Y cheesecake. Okay, the cost is 5 ringgit 1. Total cost, okay, for making X chocolate cake and the Y cheesecake, okay, is 4X plus 5Y. Okay. So this 4x plus 5y is a linear expression if we want to determine the minimum value of the 4x plus 5y. Okay, usually if this is cost, we want a minimum cost. Okay, cannot be we want to find the maximum cost. Okay, we want to try to minimize the cost, but we want to have a maximum of the profit. If this is a profit function, then usually they will ask to find the maximum. Okay. Then this linear expression is known as objective functions. Okay. Then usually this expression we will let it be equals to a number. Okay. So an objective function is written as k equals to ax plus y. This is the what I say. Let it equals to a number. That number is a k here. Okay. And then you got to know how to find the k. Okay. So after that, okay, I will go through how to find the k. But before that, okay, we will see if a different k, what will happen to the line. Okay, to this graph, the function graph. Okay, we look at this. We do this activity. Okay, this is the one. Okay, if I come back to the textbook, okay, we go to a bit. Okay, so actually this question you have three inequality. Number 1, number 2, number 3. The 3 constraint. Okay, so the 3 constraint the graph already drawn for you, and then they already find the regions. Okay, now with this objective functions, this line, okay, we want to see, okay, this line, how we draw this line, okay, and then if the value of this p here, or just now is the k here, change, then what will happen to the line? Yeah, so we come back to the graph. Okay, so the 3 inequality you see here. Okay, this is a 3 inequality. Okay, the first one, x plus a 2y smaller equal to 600, x plus y smaller or equal to 320, 5x plus 2y is smaller equals to 1000. Okay, let's say this is a 3 inequality. Okay, so you get the 3 line, and then shade the correct regions. Okay, so remember that they will label the 1 until 7, and then determine the region. Okay, and then shade the correct regions. Okay, after that, The red color one is the objective function line. Okay, first of all, they let the p is 0. Okay, so this is how the line look like. Okay, then if I drag the value of the p become bigger, you see what happened to the line. Okay, it will go parallelly. Cannot move some more already. This is maximum. Okay, actually is not good enough. Okay, because always this line we want it to move parallelly. Start from the first line that you draw. Okay, you just use a ruler. Okay, move parallelly, push parallelly. Okay, and then go out, go out, go out some more. You got to imagine now. Okay, go out some more, parallelly. Okay, and then you have to see where is the last point. Okay, that line touch. Okay, what means that point? The point means we only we only interesting with the corner point, or we call it vertex. Okay, the corner point means the intersecting point of the line. Okay, this here we have a 3 blue color line. Okay, and then the 2 axis. Okay, our x and the y axis. So we only interesting with this. Okay, the intersecting point. Okay, so we push the red color line parallelly, and then we see which point is the last point that the red color line leave the region. Okay, that one will be the maximum. Okay, then which one is the first point? That one will be the minimum. Okay, so the first point actually is here, 0, 0. Okay, so usually they will not ask for minimum cost lah. This kind of question usually they will ask for maximum profit. Okay, but sometimes they do ask a minimum cost. Okay, so will be the 0, 0 actually if the minimum cost. For this case you look at the region. Okay, intersecting point or the vertexes we have this point E here, and this point 200, 0 here, and then 120, 200 this point, and then 40, 280 this point, and then 0, 300 this point. Okay, some you can read from the graph drawn the point. If some they cannot read, but you cannot show the examiner, this one you have to do at the side. Okay, senyap do at the side. You got to solve simultaneously. I give example this point, let's say this point you can't read from the scale, okay, from the graph. Okay, so you got to solve simultaneously this line and this line. Okay, you see I touch a line, this line and this line. Therefore, you got to label clearly this line is what equation, and then this line is what equations. Okay, if you need the point. If you don't need the point, don't go and solve one by one, wasting your time. Okay, usually you will just have to know at which point, okay, the line leave the region. Last point. Which one is the last point? You go and find the last point. Yeah. So we come back to the example. Okay, look at example 4 in your textbook. Okay, I didn't teach yet how to get the value for the linear expressions. Just now the K or the P there. Okay, we look at this question first. Okay, same thing. The 3 inequality, okay, is done, and then the region is found. Okay, here they didn't tell you they didn't tell you what is the equation of the inequality, and then they just show you the 3 line, and then they just show you the 3 how to say the intersecting point. Okay, and then they also tell you what is the objective functions. Okay, but the real exam all these are not given. Okay, you have to do by yourself. Okay, write out the inequality, check the region, find out the intersecting point. Okay, and then find out the what is the objective function. All you have to done by yourself. Okay, by using a suitable value of k, draw a line k equals to x plus 2y on the graph. Okay, so this is the objective function. On the same graph, draw a straight line parallel to the line that passes through each point of the vertices of the region. This one you just follow the instruction. They ask to do this, then you just do this. But if the 10 marks questions are, you don't have to draw for all the vertices. Okay, you just push the line, okay, and then see which point is the last point. Okay, it touch, the line touch. Okay. So first of all, you got to choose a suitable value of the K. So what value of the K here? You have to choose. Okay, how to choose? Okay, you go back, you go to the second, next page. Here is this. Okay, how to choose the value of K. Okay, it's just very simple. Okay, if your objective function is K equal to AX plus BY, you just get the A and the B, find the common multiple. Okay, for me, I'm not going to find the common multiple. I will just times A times B. Okay, A times B, there will be the common multiple already actually. Okay, and then multiple of that number. Okay, let us look at this example. Okay, here the A is 1, the B is 2. So 1 times 2. Okay, the A is 1, the B is 2. So I just get A times B, which is 1 times 2. Okay, which is 2. Okay, I just use any multiple of the 2. Okay, for my K. So you see here, the first line, okay, they choose K equals to 4, which is the 2 times 2, okay? So you let K equals to 4. Okay, then draw the line. You must have one value first. Okay, sometimes you will feel your value that you use is not suitable because of the scale. If you think this value is too small, then you use a bigger one. Okay, let's say times 10. Okay, then you will get 40 already. Okay? If this value is too big, then you use a smaller one. Okay, we do the questions. Okay, I will still show you how to get a suitable suitable value of this K. Okay, so now we see if you let the K is 4, then you need to build the table. Okay, small table. So remember this. Okay, so you let 0 and the 0. Get the x and the y intercept. This is why I say sometimes you use this number is too small or too big. Okay, that's not suitable with this scale. Okay, so now we see example x is 0, then 2y is 4, so y is 2. Okay, y is 2. So you mark here 2. Okay, then the other one, when y is 0, okay, when y is 0, then x is 4. Okay, so you mark here 4. So you draw the line. Dotted line is better. Okay, then after that, this is the first part. Okay, part A, they call what? Use a suitable value K. Okay, by using a suitable value K, draw a line. Okay, drawn already. On the same graph, draw a straight line parallel to this that passes through each point of the vertices. Okay, so here got how many vertices? 1, 2, 3. 3 vertices. So you just use ruler, make sure it's parallel. Okay, push. Okay, the first that you touch this point, then you draw the dotted line. Okay, then continue. Okay, the ruler again, push, parallel, parallel, parallel. Okay, this is the second one. Dot, 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 dot. Then you draw the parallel line. Okay, okay, last point, push. Okay, then this is the last point that the line will leave the region. Okay, if the question asks for maximum, this one will be the maximum. If the question asks for the minimum, this one, because this is the first point, it enter the region. Okay, so this point will be the minimum. Okay, what is the meaning? Okay, we see part 2, part B, sorry. Okay, then find the maximum value of x plus 2y and minimum value of x plus 2y. Okay. Actually, I would like to write this one as a function. Then the k is just a value. Okay. I will write this is as a function. So I will write p. maybe this is function p and x plus 2y. Then k is a small k. Okay, then this k is a value that I put in. So then find the maximum value of p. I will write this as p. Okay. Again, find the minimum value of the p. I will write this as p. Then you will not get confused. Why suddenly p and then why suddenly k? K is a value. Very confusing. P is a function. Okay, so I put capital letter. Okay, so maximum of the p, it will happen, okay, at the last point when you push the objective function line, leave the region, the last point. So this is the one, 1555. Okay, so substitute the maximum point of the shaded region 1555 into this. Okay, I will rather to put this as p lah. Okay, so this is a p and this is a p. Okay, if not, you will get confused the p and the k. Okay, so the maximum value of the p. Then you just substitute x as 15, y as 55 into these functions. Okay, then you get 125. Okay, then minimum. Okay, minimum is the first point it enter the region, 15.8. Okay, then same thing, substitute inside the function of the p. Okay, so minimum value is 31. If this one is asking, example, the profit, so means the maximum profit will be 125. Then the minimum profit will be 31. This is the meaning. Okay, maybe you cannot see the clear picture yet. Okay, we try a few more example. Okay, after a few tries, I think should be okay. Okay, we go to this example. Okay, example 5. This one is start from the beginning. Okay, kosong. This is definitely the 10-mark questions. Okay, you need to write yourself the inequality. Okay, and then draw. Okay, and then find the region, and then get the objective function, and then draw again, and then answer the questions. Okay, this is 10 marks. Okay, this question is very good in the way they give you this, they terbalik ask you what is this constraint. Okay, I think so. This is the third constraint. Okay, that you need to write it out in the words. Okay, here the part B. Okay, so we go through the questions. Bouquet of roses. Okay, why bouquet of orchids? Okay, so there are two types of things. Okay, one is a rose and one is an orchid. The time taken to arrange a bouquet of roses is 20 minutes. Okay, and then for orchid is 30 minutes. The process of arranging the bouquet of flowers must be based on following constraints. Okay, the number of a bouquet of orchid must not be more than twice the number of bouquet of a rose. Yeah. Okay, so here the keywords is must not be more than. Okay, if more than is like that law, must not be more than like this law. Got equal sign or not? Got equal sign or not? Can be equal or not? If equal, is it fulfill must not be more than? Okay, fulfill. Okay, so this kind of sentence not is very confusing, so you got to be careful. Must not be more than. Okay, it's smaller and equal. This one you can write in the list. You know, that day my notes, you print out, okay, the list, the summary for smaller than equal to, you can add on this must not be more than, you add on one more. Okay, one more keywords. Okay, for this symbol. Okay. So the number of a bouquet of orchid, this is Y, and then twice means 2 times the number of bouquet of roses. Okay, this is X. Okay, so this is the first inequality we have. Okay, second constraint. The number of bouquet of must be at least. Okay, the keyword here is at least. Okay, at least means what? Greater than or smaller than. Okay, I call out my list. You all don't want to answer my questions already. You all answer question when I ask. Hey, you're still there or not? Someone on the mic. If not, then I'm talking to myself. Yes,
Why?
critical. Is it you?
Yes, it's
I
me.
can recognize your voice. Okay, so at least is this symbol bigger than or equal to? Okay, so just now is what I want you to add to. Must not more than. Not more than. Okay, not more. Yeah, is here already. Okay, not more than is here. Okay, so correct lah, huh? This is a symbol. So at least is this is greater and equal. And this is greater and equal. Okay, greater than equal. Okay, so the number of bouquet of orchid is y. Okay, at least this symbol. Okay, 1/4 of the number of bouquet of roses. Okay, so it's x. Okay, so this is the second constraint. Okay, by writing the first inequality, second inequality, I get 2 marks already. Okay, this is part A. Okay, part A, look at the questions. Write a mathematical model involving a system linear inequality to represent the constraint 1 and constraint 2. Okay, this is the part A, I'm done. Okay, now we go to part B. Okay, the third constraint, which is represented by the pink region in the diagram. Okay, here. This one. Okay, is the time taken to arrange the bouquet of flowers. Write the constraint in words. Okay, the time taken, actually is given also, time taken. Okay, because the time taken, how to say, for to arrange rose is 20 minutes, arrange orchid is 30 minutes. Okay, so you can get 20 minutes times the, okay, is it something wrong? 20 minutes for rose, so 20 times y times x, and then 30 times y. Let me see. You all can help me to see also. Okay, and then look at the, how to say, the solutions. First, they find gradient. Then they find the, how to say, the equations. They find an equation of the line. Then what's the meaning? 20, why is 20y? Oh, I didn't get it. Is it I don't care about the one given in the text? Because 20 minutes should be the one belong to the x. But now is 20 is y. Is it I'm wrong? 20 is x, right? 20 is for the rows, ma? Oh, so confusing, these questions. Okay, you can discuss with me. Okay, I can see this this part is mistake lah. Okay, first of all, we want to find the, how to say, the equations of this pink color line. Okay, so how to find the equations? Okay, we use a gradient. Okay, and then the y-intercept. Okay, so we write out as a y equal to mx plus c. Okay, so the gradient, so you use a gradient. So use a gradient formula. You get the gradient as a -3/2. Correct or not? Let me think. I use another formula, which is negative y-intercept over x-intercept. Okay, -3/2. This one correct. Okay, unless the line is wrong, then I don't know. Okay, then the equation of the straight line. Okay, I will use y equal to mx plus c. So y equals to mx plus c. C is a y-intercept 60. Okay, then I don't want the fraction, so I times 2 times 2 to every terms, 20. Next, this one move to this side, so plus. Okay, then almost there already. You see, because given in the question is 20 minutes is for the rows so should be 20 is times x but here is 20 times y Okay, let us change the questions already. Question is wrong. Okay, for rows is 30 minutes. Correct not? Because x is 30 rows is x Someone help.
Yes,
Start.
yes.
Correct, Okay, so change the questions. Ayo, see? Go where idea? Okay, change the questions. The time taken for rows should be 30 now. And then this one should be 20. Only correct. Okay, because x is rows rows should be 30. Okay, and then y is octet. So octet must be 20. Now only correct. Okay. Because you got to base on the question. When you do until here, it's not enough. Okay, because the question is 20 and 30. Therefore, you got to times 10 to the equations. Then you end up with this. Only is matching with the question that the 20 and the 30 minutes. So here you remember this one will be the minutes. Okay, so if you change to hour, let's say, or you want to remain in minutes, but not nice, this big. So you 1200, you divide by 60. Okay, so is, am I right? Am I right? 120 divided by 6 is what? 120 divided by 6 is what? 20 Why is 2?
20.
20 This is minute, minute, minute So 1 hour is 60 minutes So I divide by 60 correct So this is 20 Ayo, why got so many mistake one? So it's 20 hours. Okay, 20 hours. Ayo, tak boleh tahan. Okay, so this is 20 hours. They want to set some challenging questions, but the mistake is here and there. And then I think this is also mistake. Why I say this is mistake? You see, now you have a 30x and then 20y. Okay, and then it's 1200, which is a 20 hours. Okay, and then this they shade the region is below. Am I right? The pink color pink region. You all can see as pink or not? You cannot see your book. Okay, the screen here cannot see so clear. Okay, the pink one is below, and then the y is on the left, and then it's positive. So below should be this symbol inequality this sign. At least let us check. At least is bigger than should be at most. Okay, if below the line should be at most. Wow, pening. Okay. Almost like everything wrong. Okay, so this one change to at most. So you can change in your books. So change this at least to at most, and then change this 2 to 20, and then change just now the 30 and the 20 terbalik. So this is a sentence you're going to write out. Okay, the total time taken to arrange the bouquet of flower is at most 20 hours. This is a sentence that they want you to write out. Okay, the part A is they give you in words. Okay, you write out the inequality. Part B is they give you the inequality. They didn't give you the inequality. It's from the graph. You write out the inequality and then matching to the questions. Okay, and then write out the constraint in words. Okay, this kind of question is really kebat lah. So far past year we didn't see yet. It's really challenging, this type of questions. Okay, first time also I see this type of questions. Okay, I'm not sure last year because last year we can't see the questions, so I'm not sure last year how they come out these questions. Okay, previous year I don't remember I see this before lah. Maybe got, but seldom they come out. Okay, now we go to part C already. Okay, construct and label the region R that satisfy the three constraints above. Then, using the same graph, okay, find blah, 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 blah. Okay, before that, you got to construct and label the region R. Okay? How? One by one, no, you got to do. Okay, this is the one of the line. Okay, this is another line. Okay, the first constraint is y smaller and equal to 2x. Therefore, the first constraint you got to draw is y equals to 2x. Okay, what is the small table you need to get the value? This type of graph is because not the type of y equals to mx plus c. No c here. So you cannot use a 0 and 0. You only can use once. Okay, 0, and then this one also is 0. Means one of the point is at the origins. So if you put y is 0, you will get x is still 0. So there's no point for you to put the y as 0 again. So you got to find another value. Okay, see the, how to say, because one line is drawn for you already, so you know the scale actually. Okay, so look at the scale here. Okay, so maybe you can choose maybe at 30 or 40. Okay, if you choose 40, then the y value is out, then maybe you choose 30. This is how we choose the value for the x. Okay, let's say you choose 30 here, then 30 times 2, so the y value is 60. 60 is still here. Okay, so 30, 60, this is another point. Okay, and then with 0, 0, and then you draw the line. Okay, so this is y equal to x line. Okay, how about this? Y equals to 1 over 4x. Okay, this is the second constraint. Okay, so same thing. Okay, first point will be 0, 0. Okay, second point. Okay, this one you can put 40 for the x. Okay, then divide by 4, so y is 10. So 40, 10. This is the point. Okay, 1 point, 2 point, draw the line. Okay, so I have 1, 2, 3, 3 line done. Okay, now I want to find the region. Okay, you can use my method label. Okay, for those can see very fast, you will know the region is here. Okay, if I use a labeling, okay, so if labeling, you have to remember this type of questions, the x and the y cannot be negative. Okay, so you see there's no negative part for the x and the y. Okay, so actually this type of a question is quite easy compared to the like linear law or that you need to consider the negative part. This one no negative one because the x and the y is the number of a bouquet. Number of bouquet cannot be negative. So this is why the other constraint actually is x must be greater than 0 and y must be greater than 0. Okay, so it's bounded by x and y axis. Okay, actually it's more simple. Okay, and then the first, how to say, the third constraint, not the first, the third constraint, you know already, is below the graph. Okay, so if you want to label, you can label this way. We don't think that it's not bounded. We don't think that. Okay, so we can don't consider this area, and this area. Therefore, actually, the area we consider is only this, label 1, 2, and the 3. Okay, so for the first constraint, which is this, okay, which is this line, okay, smaller than, okay, so below. Okay, so this one take 2 and the 3. Okay, second constraint is this. Okay, this is bigger than. Looking at this line, bigger than, so it's above. So it's 1 and the 2. Okay, the third constraint, okay, is already given. Okay, it's below this line, 1, 2, 3. Okay, the third constraint is 1, 2, and the 3. So which one share the same region? Okay, 2. Okay, this one share the same region. 3 here don't have. Okay, 1 here don't have. So the answer is region 2. Okay, shade the region. Same thing, shade the region like this. Okay, and then label it R. Okay, so I have done the first part before I answer the questions. Okay, come, we go to the questions. Okay, find what? Use the same graph means you've got to use the graph and find all this. The minimum number of bouquet of an orchid if the number of a bouquet of a roses is 30. Roses is what? X, right? Okay, means X is 30. Find the minimum of the Y. Okay, so you draw X equals to 30, the line. X equals 30. Okay, X equals 30. Okay, this is a line. Okay, vertical line. Dotted line, please draw. Okay, X equals 30. Okay, you see this line in the region, only this part from here to here. This one will be the maximum. This one will be the minimum. Okay, so read from here. Okay, read from here. Cannot read, right? Okay, so what you can do is, okay, because you know this line is this. Okay, so you can substitute, okay, when X is 30 inside here. Okay, so you get 7.5. Okay, but 7.5, the bouquet of flower cannot be a decimal, must be whole number. Okay, so here is 7.5. You cannot put 7 because 7 is already out of region. So you got to put the next number, which is 8. So the minimum number of bouquet of orchid is 8. This part you need to analyze a little bit. Okay, so first thing, okay, you remember you put the line X equal to 30, and then okay, this line cut through the regions here to here only. So the Y value that you can take is only from here to here. Here will be the minimum, here will be the maximum. This is how you read. Okay, now we come to second part. Second part, you need to write out the functions. Okay, the maximum profit of the trader, you want to find the maximum profit. Okay, if the profit of each bouquet of roses is 35 and the orchid is 25. So roses times 35, 35x plus 25y. Okay, let it be a function. 35x, 25y. Okay, let it be a function. Okay, so let's say, okay, this one you let it be the k. I would like to let it be the p lah. So can see this is a function. Okay, now what suitable value that I can choose? Okay, the way of the textbook how they write, I not really agree with it lah. Okay, so how to choose the value of the k? Then you can write this as a k. Okay, so 35 times 25. Okay, this is how I choose the value of the k. 35 times 25. Okay, this is 875. Okay, if I choose the k is 875, what will happen? Okay, so I need to draw this line. Okay, I build a small table. Okay, when x is 0, okay, so 25y is equal to 875, so divide by 25. Okay, so this is 35. Okay, then when y is 0, 875 divided by 35 is 25. This is why the propose you to use the K as the common multiple. Okay, now I check and see 35 and 25. Is it easier for me to plot here? Yes. Okay, it's in the scale here. Okay, so my y-intercept is 35, so I plot here. Okay, my x-intercept is 25. Okay, I plot here. Okay, dotted line. Okay, but you see they draw here the green color one is so tiny. Can also they use a smaller number. Okay, I use a bigger number, I have this line. I don't care one. Just push the line, okay, up and down as long as parallel. Okay, so now I want to know, okay, if I push the line parallelly, which point will be the last point for the line to leave this region R? Okay, is this point or this point? Cannot be this point, this point is the first point. Okay, so you can do it inside your books. Okay, and then use your ruler and push. Okay, I do already. Okay, because on the screen I can't do. Okay, so I know that it will leave the region at this point, the last point. Okay, but you see the last point they don't mark at the intersecting point. They mark a bit down here. Why? Because the intersecting point here is not a whole number. When you have this kind of questions, I tell you, this is really headache. You may consider don't do this question. If you have this kind of questions, the intersecting point is not in whole number. Okay, but still can be done actually. Okay, if after you see this kind of question, because this kind of question not many. Okay, mostly they will give you the intersecting point is a whole number. Okay, so how? Okay, how do I know the intersecting point is not whole number? Okay, now you know already this is the last point. The function, the objective function line will leave the region. So you just sort simultaneously this y equals to x with this line. Okay, this line is what? Wait, this line is the 2y plus 3x equals to 120. Okay, this is the equations. So solve simultaneously. Y equals to 2x, substitute here. Okay, this is 4 and 3, so this is 7. Okay, so 120 divided by 7. 17.14. This is what I say that, okay, this is not whole number. Okay, and then the surrounding, okay, that still fall in the region and then is the highest. This is the point. Okay, you got to analyze a little bit. Okay, I repeat, you know already this is 17.14. You can substitute back into the y. Okay, 2 times this 17.14. Okay, y is this times 2, 34.29. Okay, so you can choose the point that very near to this 17.14 and 34.29. Okay, but you have to make sure the point is still in the region. Okay, so this is the point. Okay, I don't know whether you understand me or you don't understand me because you are so quiet. Hi, hi. How? Turning already. Hi, hi. Hello. Kritika. Only Kritika will answer me.
Yes.
Yes. Do you think can do?
I still so like whoa.
Blow. Okay, which part you are blow?
No, not blur. Like if I see again and read again, I'll understand lah.
Okay. So I hope you go through again. Okay, maybe this is not a good example that I should show you first. I should show you the simple example. I don't know whether I can find it or not. Okay, but now the time is short. Okay, so we just go through it. Okay, let's say you know already this is how you get the maximum point. So you just substitute back into this function, and then this one will be your maximum profit. Okay, so now you will have problem in finding the maximum point only. Okay, because okay, the intersect, as I say just now, the intersecting point is not a whole number. Okay, when we solve simultaneously, these are two equations. Okay, now I still have 8 more minutes. I don't think I can go through another example. Actually, I have another example. Okay, so this example you go through by yourself, okay, because you got solutions. You try to see. I don't know, I'm not sure whether this example is more difficult or not. Okay, then I'll give you the homework. Okay, anything that you still have doubt, then we will discuss next lesson. Okay, when you do, I think you will be more clear which part you don't know. Okay, so next lesson you tell me which part I will need to repeat so that you can settle your homework. Okay, your homework is these questions. This question you remember the previous exercise. You still have number 4 you didn't do yet. Okay, so this is a homework for today. Okay, and then you try out these 2 questions. Okay, you try out these 2 questions. Here got 2 questions. Okay. Anything that anyone that can think of want to ask, you can ask now. Then I try because now we still have like 5 minutes. Okay, then I will try okay to answer your questions. Anyone? Tak ada kak. Yo, you're so quiet then I'm worried. Okay, I try to explain that point. Just now that point. Okay, how I going to draw it? This way and this way. Okay, this is the line y equals to 2x. This is the line, the 2y plus 3x equals to 120. Okay, then here the intersecting point is what? Just now textbook. 17.14, 34.29. 17.14, 34.29. This is the intersecting point of here. Okay, the region is here. The region is here. Okay, so now we have to choose a point that near to this, but is the maximum for these regions. Okay, so how? Okay, you see, let's say 17 is here. Okay, and 18 is here. This is for x ma. Okay, here is 17 and then here is 18. Okay, and then 34.29. So let's say 34 is here. Maybe the book is wrong. Okay, lama, low battery. Tapi he's here. Okay. Wait lah. Okay, the book can be mistake one though. Okay, 34 is here, and then I try to draw out the grid, 35 is here. Okay, Therefore, you see this intersecting point, 17.14 ma is in between 17 to 18 lor, 34.29 ma, so in between 34 to 35 lor. This is the meaning. So it's either we can't choose these 2 points. We cannot choose this point and this point. I put in red. You cannot choose this point and this point because these 2 points is not in the region. Okay, but okay, I put in purple color. Purple. You can choose this point and this point, too light. Okay. I'm not sure whether you can choose this point or this point also. Okay, never mind. I will draw in the graph paper and show you. Okay, because maybe this point, if you choose, is out, not in the region. So I got to test. So this is why I say, if the intersecting point is not a whole number, then this question will be difficult to choose from. Okay, so I think that's all today. For today, I still unable to explain to you this. Okay, I will draw on the graph paper. If possible, I will put in a WhatsApp group. If not, next lesson I will explain to you. Okay, so you try to do the exercise first. Whatever you can do, like example, you can write out the constraint. Okay, you can draw the graph. You can define the region. It's very good already. Good enough already. Okay, then the answer question part, if you cannot, then we will discuss during the next lesson. Okay, so wait for a while, I take attendance.